Now, a coterminal angle, that's when two angles, and again, they're in standard positions, so then we know where we're starting, and they have the same terminal side. And that's said to be a coterminal angle. So again, they have to be in standard position. So once again, that means my vertex is on my origin and my initial side is on that positive x-axis. And so what it's saying is, again, let's say this is right here, okay? And now I'm claiming that this measurement is 140 degrees. Well, if we go the opposite, right, we're going to go clockwise, and we end at the same spot, that's negative 220 degrees, right? Because we're just completing that circle. Those angles are saying, they're saying that 140 and 220 are in fact coterminal angles. So essentially what we're saying there is they start and end at the same spot. And this is really important when we start evaluating, when we start using sine and cosine and tangent. It's going to make life really easy because then I don't have to think about if I get a really, really large angle, I can compare it to a very, very small angle. Okay, so for example, one, negative 150 degrees is coterminal with 210. Would you say that's true or false? And how you could figure that out, right, is you could figure it out is if they create 360. So it looks like this guy would be true. And let's see, let's just give ourselves a visual. So if you're going to draw your standard angles on your own, you'll give yourself a x-axis, x and y axes. I'll put it in standard position. So initial side on the positive x. Negative 150. So I'm definitely approximating because I'm going negative. Now remember, like if I'm going negative, this would be negative 90 from there to there, right? So I need to get to negative 150, so it looks like I need about 60 more degrees. So again, maybe not the best. Let me actually go a little bit further. So this, and again, giving myself that direction piece, this is a negative 150 degrees. And then if I'm trying to figure out what the rest of this would be, right, that would be the completion of the circle. So 210 degrees. Now, how many coterminal angles does negative 150 degrees have? Well, let's see. I could, I could go around the circle clockwise, go one full rotation and then additional. Well, that's coterminal. I could keep doing that. That's coterminal. I could keep doing it. That's coterminal. And then I could also go counterclockwise. Well, that's coterminal. And then I could go around the circle once and then go again, coterminal, coterminal. So that's why this has infinitely many coterminals. There's no stopping us. We can keep going around the circle as many times as we'd like. All right, example two says draw each angle, identify which quadrant it's in, and identify a coterminal angle. So let's just refresh our memory real quick. This is quadrant one, quadrant two, quadrant three, and quadrant four. It is nice using Roman numerals. It's just best practice. So we're going to use that information to draw each angle and then tell you what quadrant it's in. So 135 degrees. All right, let me just give my quadrants again. This is one, two, three, four. Um, Remember from here to here is 90. And let's just go around the circle. And then if I stop there, that's 180. That's another 90, so that's 270, full circle 360. Now, if it's positive, I got to go counter. So I know might have to be more than that 90. And if you think about it, halfway would give me another 45, right? Because half between 90 is 45. So it looks like it probably, again, standard position. So vertex on the origin, positive x-axis. Looks like it's going to go right in the middle here. And once again, please, please, please show us the direction. And if you actually know the angle, it's great if you put it there. So this is telling me it'd be in quadrant 2. Now, negative 120. Again, I'm going to put it in standard position. And let's think about this. Okay, well, from here to here is negative 90. So I need an additional 30 degrees. So it looks like I'll probably stop around there. And again, I'm going to mark that as a negative 120. And what quadrant would that be in? That'd be in quadrant 3. Okay. Now, it also, I forgot, it needs us to know a coterminal angle. So let me go back to example A. Well, if that's 135, what would that coterminal angle have to be? Oh, well, again, complete the circle. I'm going clockwise, so it has to be negative, so it'd be negative 225. And I will let you all find this coterminal angle. And I'm giving you a pause so you can do it. First, ask yourself, should it be positive or negative? Well, I'm going counterclockwise. It should be positive, and that would be 240 degrees. So again, those are coterminal because they start and stop at the same spot. All right, there's a lot of definitions with this lesson. The next one is reference angles. And I really have to emphasize this. These are very, very important. We're going to use them for the rest of the term. So please, please, please make sure it clicks in your brain and you ask questions if you have them. Now, a reference angle associated with every angle drawn in standard position, except quadrantal angles. So that just means it's on the X or Y axes. There's another angle called the reference angle. The reference angle is an acute angle, so refresh your memory. That means it has to be less than 90 degrees. And it's formed by the terminal side of the given angle and the x-axis. Okay, can't stress that enough. It has to be with the x-axis. Reference angles may appear in all 4 quadrants. Angles in quadrant 1 are their own reference angle. So let's make sense of this for a second. I'm asking here, what is the reference angle for 150 degrees? So what I'm going to do is give myself an XY plane. I'm going to draw my angle in standard position. So 150 degrees, that means I'm going to be in quadrant 2. So roughly like right here. All right. The key thing, and this is something all of us mess up on, is it needs to be attached to the x-axis, okay? So essentially what you're doing here, it's like you're creating a triangle. And really what we want to know is this green angle. So essentially the leftover. Now refresh your memory. This was 90 degrees. This is 180 degrees. This is 270 degrees. And when you go around one full time, we're at 360. So if our angle's at 150 and I'm attaching it to the 180, that forces my reference angle, my shorthand for reference angle, to be 30 degrees. Now it's going to change what you are taking it away from every time. So let's just briefly go through that. Like if I had, let me give myself a different color. If I had an angle that ended down here, this would be my reference angle. So it looks like, okay, yep, I'm going to take it away, or I'll take 180 away from it. However, if your angle is over here in quadrant 4, this is your reference angle. So now you're doing 360, take away that reference angle. The key thing with a reference angle, it has to be between 0 and 90 degrees. Okay, so you'll never have a negative reference angle and it can never be bigger than 90. So to make sure this is clicking, let's just go back to example A and B. And for 135 degrees, we need to find our reference angle. So remember, you're attaching it to the x-axis. So it's that angle. So if you're attaching it to the 180, and you'll probably do this math in your head, but just in case, your reference angle would be 180, take away the 135, so you get 45 degrees. That would be the same reference angle for negative 225 degrees as well. All right. I'm bummed I don't have this in a different quadrant, but so be it. All right, so now 240. Your reference angle, again, is always attached to your x-axis. That's the biggest thing. And we know this is 180. But now the order is going to be swapped, right? I'm not going to do 180 take away 240 because that would give me a negative reference angle. So I'm going to do 240 take away 180 and I get 60 degrees. Say you didn't swap the order, you just know your reference angle has to be positive. So you can just make it positive. All right. That takes care of reference angles. See you next time.